With great data comes even greater access latency. Welcome to the Trino Community Broadcast, where we transform your latency woes into fast insights. Trino Community Broadcast is a show where we cover events and happenings with the open source Trino community and show off a couple cool things about Trino as well as Iceberg today. So,
Yay, yay, yay.
so today we have our honored guest, one returning, which is David Phillips, who is the Trino creator and as well as Presto creator. And today we have the creator of Iceberg joining us, Ryan Blue. Welcome, Ryan.
Hey, great to be here.
So, Ryan, you're a software engineer at Netflix, right?
That's right.
And I guess, we'll hold off on this, but we're gonna kind of start picking into some of the things that kind of unfolded that got you to where you are today. You probably ran into a bunch of these issues that many people have seen over the years as data lakes have become a thing, and a whole huge amount of table storage. And I mean, you see this at such a huge scale at Netflix, and eventually you kind of this developed you coming upon creating Iceberg, and so we'll do a little bit of an interview here in a minute to kind of find out about that journey that you took there. Before we jump right into that. Manfred, how are we going to do the advertisement? So we've been trying to play around with how we do this. So do I just kind of go in and talk a little bit about what I've done at Starburst to kind of talk about our sponsors today?
Yeah, sure. I mean, that's a good idea, right? Like we roped you in, right? Like how you got started in the Twitter community, which was pretty interesting. Because you like started trying to get a course going and stuff like that. We noticed you on obviously David, Martin, and Dane at that stage were already in Starburst.
Yeah.
Really ripping into Trino.
Yeah, I forgot about
then
that.
Called Presto.
So yeah, that was the interesting kind of like genesis of how I got involved with Starburst was like, I've noticed whenever I was working, I before Starburst, I was actually working at a engineering company or at a cybersecurity company on an engineering team, and we were using Hive largely, and we found out about Presto, and we were gradually moving on to that platform. And one thing I noticed was like there's this huge gap of like information about there's a lot of documentation for one. Like I'm about to say a whole bunch of like horrible things about the documentation, but and David's on here, literally one of the biggest proponents of documentation and has done a great job at what we've done so far. But there's still like it's such a vast space, and with Trino connecting to all these different sub databases, it becomes something that's very difficult to manage on in an open source sense, because you're kind of relying on a lot of people who push in code to also push in documentation with that. And so a lot of people starting out with Trino, there's a good initial foundation for understanding how we are very strict on like the SQL standards and things like that. But there's like, for instance, one of the biggest confusions that I had when I came into it was like, why is the Hive connector actually talking to a Hive like running instance or query engine in the back end? Like, because most other connectors are talking to those type of instances, right? You have like an Elasticsearch connector, you're talking to an Elasticsearch database. But in Hive, you were like, why would I want to put a query engine on top of a query engine that's super slow? So, just even that, it's a hard thing to approach in terms of how do you even begin that conversation with somebody who's brand new to the project. So I started taking a bit of a whack at that, as well as like some of these confusing topics about how to configure the user memory and the system memory and things like that. Tried to make them a little more clear by starting out a Udemy course. And then basically while I was in the middle of that, Starburst kind of hired me on, and we didn't really even know that I was going to do community at the very beginning. I think the initial thought was that I would kind of be somewhere between engineering and product, and but then we saw a good spot for me to kind of take a developer advocate position, and I had no idea what a developer advocate position was. I didn't know what developer relations was, and I'm still kind of learning it. But in general, my goal as being part of the Starburst team is to kind of help engineers by doing stuff like Trino Community Broadcast, working with Martine, Dane, and David, as well as Manfred a lot of times, and bringing awareness to a lot of this stuff. So I'm really appreciative to Starburst for kind of giving me this platform and giving me this ability to do this for my full-time job while I can also get the chance to do something awesome in this open source space. So with that, like that's kind of where my role fits into all this, and Starburst in general is just taking the open source Trino and building a lot of really cool stuff on top of it, making specifically for enterprise type solutions, a lot of security considerations, ODBC drivers, like different things that we built outside of what's available in the open source. So definitely check that out at Starburst.io, and and also thanks for sponsoring this show as you always do. So with that, we're first going to hop into getting into the some release stuff, and then we're going to go right into talking the details of Iceberg. So Manfred, you wanna cover a bit of the release?
Yeah,
355?
it was release time again, right? Like the numbers keep going and the project is churning away, always bringing up new things. This time it was 355. Martine's list had a couple of things in his announcement. He always does this very succinct, anywhere from 3 to I guess 6 or so bullet points. So one of them was multiple authentication plugins. One thing that when me and Dane last year did this security training, that was like a nagging thing in Dane's side, that he's like, yeah, I know we don't support that, and it is arrived now. So now with the multiple authentication types, you can basically support multiple password authentication systems, which allows you to, it's just a small line here, but it allows you to basically hook up multiple password-based authentication systems. There's documentation about the authentication types already as well included that my team wrote, and it allows you to, for example, have LDAP like an LDAP directory configured for password authentication, and then maybe if your company has multiple because you're like merged or whatever, you can just add the second LDAP one, and then you can add a password as the third one for any service accounts, or to make sure you can still get in if your LDAP directories are offline or you have some network issues. So you can basically have multiple of these password authentication types now, which is really, really nice.
Wow.
And has been a long requested feature. So that's there. The other thing that was added was column and table lineage reporting in query events was reported. It's a bit of an under the hood thing, but it can be very helpful to look into performance stuff. And then the other two things that were mainly mentioned also is also planning performance for queries with Phoenix and SQL Server was improved. And we got the order by limit queries against Phoenix also improved. So the plumbing for that is in place now and can be added in many connectors, and we just knocked one.
Is Phoenix still a pretty big use case? I haven't heard too much chatter about it on Slack, but I don't know if like a lot of people still really use Phoenix.
Don't know.
David, you know? You heard any chatter about it recently? I mean, clearly, if people are working on it, then maybe there's still plenty of use case for it. But I haven't heard too much about it recently, so just curious. I've seen a couple PRs come up for it recently, so maybe there's like one very dedicated engineer that needs it.
Yeah, who knows? I mean, like it hasn't shown up. So like I think it was yesterday or the day before, I got an email, like a whole whackload of emails from the Apache project, because someone went through and moved a whole bunch of projects to the attic, which is like a project that's no longer maintained. And Apache Sentry was there, for example. So, and there were a bunch of others from the Hadoop ecosystem that sort of were, I guess they kicked the can, so as they say.
Yeah.
But one thing we're missing is a good way to get feedback from users on like what they're using when things are working well. Because if we don't hear about it, we either assume that people aren't using it or it just works and no one's complaining about it. But it's hard to tell the difference.
The no news is good news feedback.
Well, yeah, it's like, if it's crickets, what does that mean, right? It's tricky, right?
Yeah.
Now, the other thing that I wanted to mention, besides the multiple authentication providers, which is awesome, is that we did a massive rewrite and edit of our security documentation that we got in finally. So now we have guidance on the very important first steps of when to say what you need to do when you want to start securing your Trino cluster, also based on a lot of the information from our training that we did with Dane.
Where do I find that?
That includes working with just like, in general, in order to have any authentication and authorization added. Yeah, that's the HTTPS. You need to have TLS running. So there's a lot of information here. We have the PEM files and JKS files pages because in the past, the documentation was very much focused on the Java key store files, which is a lot more painful to manage. And we do support PEM files, so might as well sort of like point that out.
Totally.
And there's also the security overview page before. And you see also there's the authentication types page, which is the one that talks about the multiple connectors, like multiple authentication types and then multiple password authenticators. So,
very good.
Lots more coming there. We still have lots of plans, so stay tuned for that. Other things that I noticed in the release notes is that the parallelism for table bucket counts is now a bit better when compared to like a small number of nodes. Like if you have many nodes and a small number of buckets, the parallelism can be improved a bit. One thing that I thought was very interesting is the information from spill to disk is now available in explain analyze. It's a bit of a low level thing, but spill to disk generally can have a lot of, can have some performance impacts that you're not necessarily desirable. Explain analyze can help you with that. We also added some more improvements on the Hive view support. So we constantly working with the team at LinkedIn that works on the Coral library that we use for that. So there's some improvements that came in again. And then Unix time in general, there were a couple of things on Unix time that changed, like nanoseconds and like some behavior there. And those were really the only things. So it was a bit of a smaller release, but sort of only on the surface. And we're already working on 356. So
I mean, small release in terms of numbers, but in particular, like that multiple password authentication plugin is pretty. That's pretty valuable, right there.
Yeah, it's a very impactful change, right? So it's
cool. Did you have anything else you needed to cover for release, or shall we jump right into the good stuff?
No, I think that's good. Like, let's.
One thing I wanted to point out. So Ali actually, I don't know if you caught this the episode last week, Ryan, but we did this fun little thing where with this iceberg. Did you happen to catch last week by chance?
I didn't, unfortunately. It was spring break, so we were a little swamped.
Yeah, and plus you just had a baby, right? So it's like you're super swamped as is. So let me show you the fun little thing that we did. So I'll pull up real fast the previous episode. Let me just duplicate this and go to the last episode on 14.
Just look at the image.
Yeah. So if you look at this image, I initially just said, we need to have Commander Bun Bun in a penguin suit sitting on top of an iceberg. And Ali, who's our graphic designer who pulls these together, she actually created her own iceberg, not thinking to just use that your logo is an iceberg. And when one of our docs guys saw this, they were immediately thinking of this this tweet that came out from. I think it was just an iceberg scientist or something like that, Meg Thompson Munson, and she talks about how. Oh, go ahead.
Icebergs should be shown flat instead of right.
Exactly.
Or how they float. And there's a simulator that you can try out. And we tried yours. Yours works perfectly. Ours didn't work.
So picture like Commander Bun Bun sitting on top of this thing, and if we draw that same iceberg shape. We see that Commander Bun Bun just kind of eventually goes and sinks onto the bottom. But if we go ahead and actually use the shape of your maybe correctly drawn iceberg shape, that has more of a flat top, we see that it's much more stable and Commander Bun Bun doesn't go under the water. So anyways,
props to your designer.
Yeah.
So it's kind of funny. One of the reasons why we chose iceberg is that, I don't know if you guys knew this, but icebergs can be tabular. which means it has a flat top.
Oh,
So
very
that's
cool.
why our iceberg has a flat top, and I guess they're more stable that way. I don't know.
Yeah. Yeah,
But yeah,
we had some Barton from our docs team was just like he immediately sent us this as soon as he saw this graphic, and so we had to poke a little bit of fun at it and play the simulation game. So we are now on a very well supported iceberg that is now your actual logo this time. So anyways, I wanted to point that before we jumped right in, and also point out that we made this 2 episodes. Last week we covered kind of coming to Iceberg and covering a little bit of the internals from a more, I guess, engineering perspective. But we wanted to have you on today, Ryan, to kind of maybe even dig into that a little bit more, but also talk about more of the story and the kind of backstory. So. So why don't we just my first question was, I picture the 10 years that it took for something, for these table formats to start surfacing like Hootie and Iceberg. And it's just like, we really put ourselves through quite a bit of hell before we actually came in and somebody actually said, this is enough, And so I kind of want to hear, what was the actual kind of projects that you were on that brought Iceberg to the surface, and then what was kind of the straw that broke the camel's back, and you're just like, screw it, I'm making a table format.
yeah. Well, so I think everyone knew for a really long time that Hive was, just not great, especially in terms of like commits and atomicity. Like, I think all the big companies had patterns where like you could make changes to your table, but if you wanted them to be atomic, you had to swap whole partitions.
Yeah.
So I know like Twitter back in the day considered their partitions to be immutable. We did the same thing, but you could like swap them for new ones. And like that was just really, really annoying. And we knew that for a long time. I think everyone was just sort of putting off work in that area.
Mm-hmm.
But so the main problem was when I moved over to Netflix is that everything was 10 times worse with S3. So the window of time when a Hive table could be incorrect in HDFS is, kind of narrow because you're doing a whole bunch of operations on the name node one after another.
Mm-hmm.
In S3, that time is not only like your latencies are 10x, you're also contending with listings that might not be consistent. And so like we just hit all of those problems at once a lot harder.
And when you say listings, let's maybe somebody's not as familiar with like, so you're talking about the file listings and like a directory kind of Hive stores things at a directory level, and every single time you do a read, you're needing to list out a whole directory, right? Versus just a file.
That's exactly it. So, okay. The evolution of Hive tables was, hey, we're putting stuff in a directory and it's not quite scaling, to let's use multiple directories and try and figure out from the names which ones we should use, scan. And then it was listing directories and, going and finding out what there is not scaling. So let's put those in a database. And that's kind of where it stopped.
Yeah.
So you have a database of directories, and then you have a whole bunch of directories you need to go list and to get the files.
Yeah.
So that was very painful for us.
And what does Iceberg? And we kind of talked about this last week, but for anybody who's just tuning in, like, what does Iceberg do in contrast?
Well, so instead of storing state in two places, a file system, which is not transactional.
Yeah.
I mean, clearly, especially if you're on S3 or if you were. And then in a database, what we do is we use all the formats that we've built up for fast data scans, and we keep a persistent tree structure that describes all of the files in the table. And so that's a lot better because with each file, you can store additional metadata. So like, your ID columns, min and max for every data file. So you can pretty easily see, like, if you're looking for a certain ID, it is or is not in a data file.
Yeah.
So we improve on it there. And so like we have these lists of basically data files called manifests, and we manage a whole bunch of those. adding or subtracting manifests and rewriting them in order to have this tree of all different versions of your table in parallel.
Very cool. So okay, so what did it take like a lot of work to like, you know, say, hey, I'm putting my like the stake in the ground, like we need to actually solve this problem. Did you have to do a lot of convincing at Netflix to say this is going to be I mean, because this is a lot of work. This is not like, okay, I mean, it's up for a company like maybe, you know, Netflix to handle something like this, but this is, you know, I don't know, maybe is it 3 years or 4 years now in the making?
Yeah, I want to say like 4 years almost.
Yeah.
I think I started August 2017, something like that.
Yeah.
So you started and pretty much immediately decided like this has to go open source, this has to go into Apache, or did you like do this as a Skunkworks project internal first and then tipped it over, or
how? We did this internally first, got it working, basically got it to you know, where we were pretty happy with this as a concept, you know, because we weren't really sure that it would actually be faster planning queries and that, you know, we'd be able to pull it off essentially. The metadata for a given table is actually huge. And there's a reason why everyone tried to attack this problem by scaling the metastore and fixing the metastore, which was actually one thing that we were also contending with. And one of the convincing arguments was the ability to basically, because all of the job planning and work is done in the cluster, it's distributed, it's not managed by the metastore, you're making a lot lighter weight metastore that just has to track a pointer to a table location. Mm-hmm. So the work is distributed amongst all the Spark drivers or Presto coordinators rather than putting it all on your central metastore.
Yeah.
Yeah. So like, anyway, we used to attack the problem by trying to scale up the metastore. And that, I think, was one of the primary distractions why we didn't end up doing this before.
So from discussing this last time, I understood that basically the metastore is still needed, but it's like super shallow. So do you foresee that like you're actually going to get rid of the need to have the Hive metastore by default and have some sort of other even lighter way? Like literally it's like one table you're using or so, right? So
yeah,
do you foresee there's being some other structure that's even lighter and like also less pain to like start up and like run as a server?
So I think that there is a lot of potential for doing that. Like you could literally just run a machine that has, you know, some directory of files and keeps track of it without a database. All it has to do is basically lock and do this swap operation so that you get a linear history of versions. Mm-hmm. We actually think that there is going to be a lot more innovation here, and that's why we designed the APIs inside of Iceberg the way we did. So you basically have an API that is, give me the latest table metadata or swap this table metadata for new table metadata. And those are just objects so that you can use the system that we've provided and use like the root JSON files, or you could plug in a database there. I think that there's a you know, pretty rich space of ideas here. But what we wanted to do was make this something where people could bring their own metastore and really like customize this, because we knew that no one was going to agree on a scalable metastore layer and how to integrate both Hive tables and Iceberg tables. And like, this was just something that we didn't want to have to, you know, solve for the world and for every tech company ahead of time. So we made it super easy to plug something else in because we wanted to work with other people. You know, this is a layer where we want convergence, because no one benefits from having their own formats or anything like that. It's like a file format where if we all work together, we can really make this amazing and feature rich. And I think that that's kind of what we're seeing, where you can have, you know, we're talking about secondary indexes in the Iceberg format, Delta files and things like that. And I don't think that we would have gotten there if it weren't for having an open base and a broad community. So that's why we were targeting that from the start.
Very cool.
Yeah, we noticed that too. I mean, like having a large community and of ideas and stuff like flowing into Trino, all the connectors we're getting and stuff like that, it's not possible to do this on your own. Like, and it's great to hear that your community is also like very much thinking in that way. So where does it sit now though? Like, what's the common usage now? Is most people still use a normal Hive metastore and have Iceberg underneath, or?
Well, so it kind of depends on what normal is. Kind of like you guys with the success of a connector, like you don't get much data back. I think we're kind of the same way where, we talk to companies that are using it, like, Apple and Adobe and contributors. But I don't know how many people are just using the Hive Metastore stuff out of the box. I would love to get to know that better and like shake some people and say, stop using the Hive Metastore. We can do so much better. Let's all work together on this. So we don't really know how many people are using it outside of like large tech companies. It could be a ton. It might not be. We do support the Hive Metastore out of the box, as well as Glue now. There's a locking Glue catalog. Nessie, if you're into experimental catalogs, and we're also reviewing a PR for just a plain JDBC connector catalog.
Okay, so you could file into any JDBC file database.
Yeah, and like I said, I think most large tech companies have a distributed Metastore. Like Netflix at least has turned the Metastore into a distributed service. We run the Thrift API and proxy and do a lot of tricks there. And so we knew that this was an area where people needed to be able to plug in their own things. And that's why it's well documented how to do it. And so I'm hoping that next maybe we can figure out as a community, how do we want to track this data to get better or richer interaction there?
Cool. So you mentioned big users. Obviously, you're at Netflix. You mentioned Adobe, I think, and Apple. Are there some other ones you can tell us that that you're aware of that are in your community? Like how large is your community, A, of users and A, of contributors? Right?
Yeah. So we have a few large tech companies, like the three you mentioned. LinkedIn, Airbnb, Expedia have also contributed significantly. I think Airbnb has like 1 or 2 committers and PMC members. Salesforce, because someone from LinkedIn moved to Salesforce, so they've got a PMC member.
Nice.
Then we've also got contributions from a large set of companies as well. I've seen someone from eBay. I've seen people from Airbnb. Stripe. I'm always leaving companies out, so
I thought I saw Apple giving a talk on Iceberg at least, so I'm pretty. They may be in the loop.
Apple. Apple's a huge contributor. So Anton over at Apple and Russell as well. They contribute a lot. So
cool.
They've been working with us on some of the row level plans in Spark. So merge into, delete from, that actually rewrite whole data files instead of just trying to add or remove data files themselves. And then they've also been really instrumental, particularly Russell, working on actions. So you can, in most cases, like maintain tables from a single node. But if you're looking at really large tables and you want it to go quickly, parallelizing that work is really beneficial. So Apple has been contributing actions that basically use Spark under the hood to do that. And then also what's really cool is taking those actions and then repackaging them as stored procedures. So you can call expire snapshots on this table and have a parallel action that runs SQL to maintain your table. So really great contributions from Apple. I am so sorry that I left them out.
No, only reason I had seen them talk of theirs is when you're trying to Iceberg still getting new on the kind of like a awareness phase, and so I see a bunch of talks from you and I Google it, and then like I did happen to catch this like one Apple talk that was very good in detail, so I figured they had a lot to do with it as well.
It's really amazing to have a community like this.
Yeah.
I'm super happy about it. Like, this is what we need. One thing that we wanted was this to be like really community led, and for everyone to feel like they own the format, because this is your data, right? You can switch processing, flavors and ETL patterns. But your data is going to live for a very, very long time. So it's very important that it's open, well specified, and truly owned by the community.
I'd like to get into a little more too when we're talking community, like so at what point did Trino like kind of catch wind of Iceberg, and when did we get involved? This is kind of more geared towards David, but also kind of for both of you, I guess. But David, do you want to take a stab at like what was when did you hear about Iceberg, and kind of how did we kind of start getting involved?
So I first heard about it at a meetup at Facebook. I think it was in early 2018, if Ryan remembers. And then it was just like a presentation. I guess like the code was there, but we didn't have any Presto integration. And then eventually, I'm sorry, I forgot his name at Netflix.
Parth?
Parth, yeah. Put up a PR for Presto support, and I actually ended up working with them quite a bit on getting that integrated and getting it like usable by the broad community. And then we did a bunch of follow-up work to actually like make sure that there were full integration tests, that everything was covered, that the reading and the writing paths were really solid, and that we were confident that when we were writing Iceberg data that it was actually correct. Like one of the things we did was have integration tests where we'd read and write both like in Trino and Spark, and we'd verify against each other, because writing data incorrectly is like, and losing people's data or corrupting it silently is like the worst thing you can do. So we spent a lot of time on that before that we were confident to tell people like, this is something you can use in production.
Yeah.
We are very serious about that as well. So we always had a Presto connector. We started developing that in parallel, and tried to get it out in the community as soon as we could, because we realized that like Presto and now Trino is a huge part of people's data stacks. I mean, certainly a huge part of ours. Yeah. And so we definitely wanted to make sure that support was there from the beginning. And I know that it's improved quite a bit since the early days, adding metadata tables and things these days, which are pretty useful. Which, let me explain what I mean. Metadata tables are basically exposing Iceberg's metadata tree or different parts of it as tables themselves in the engine. So you can query your table, I think $ files in Presto or Trino, and it'll give you all of the metadata that we have on files as though it's a table. So if you want to find out like when files were added, or I guess not when files were added, but what data files are out there, what partitions are they in, and things like that. You can go interact with it that way. And we've actually found that very, very useful for our ETL patterns. So rather than having two separate ETL things, that one of them goes and talks to the metastore and then runs another ETL job, you can actually write all of that in the same artifact. You just query your metadata tables and then use that to affect the job that you're running on your data.
Cool. So it seems like it's a very common setup to have Iceberg with Spark and Trino, and then some ETL and other systems around it, basically.
Yeah, it is for us at least. And cool. I think pretty much everyone we work with, Trino and Spark is the two main engines.
So one thing I'm curious to know, like, and I think a lot of people, when we're hearing all these different table formats emerging, right? And so I'm just curious, like kind of from your experience, like what is the thing that kind of makes Iceberg stand out and shine, and why are a lot of people kind of moving more towards Iceberg? And this can be for both. I'll start with you, Ryan, and then let's get David's take on that as well once you're done.
So I think Iceberg does two things pretty well. The first is community. We've always, it's very important to me that this is something that can be a successor to the Hive table format. That's necessary just because we want everything operating on the same data, just like with Hive, only we don't want the format to have awkward limitations. So we've done, we've focused on community from the very beginning. with the spec, with being a very welcoming Apache community, making sure that a foundation owns the code and not Netflix or someone else, and also like making sure that it runs like an Apache community. So I think that in terms of like open, safe, reliable community
Yeah.
for the code that manages your data, we've distinguished ourselves there.
Yeah.
The other area is, I think, similar in that I think of Iceberg as forward looking instead of backward looking. So Iceberg, when we realized that we needed to fix all these atomicity problems that the Hive tables were having, we said, hey, we're going to be ripping out like basically the lowest layer in all of our data products.
Yeah.
If we're doing this, let's do it right.
Yeah.
And so we fixed a lot of things like schema evolution and table evolution. So you basically have a logical view of your data, and then there's a physical layout of the data files. But those two things are separate. So you can change the physical layout without changing your logical queries, which you couldn't do in Hive. So we fixed a lot of those persistent problems that needed to be designed well, rather than, and this is the distinction between forward looking and backward looking. We wanted to do that for the next 10 years rather than saying, we have all these things that we need to just immediately work with this format. So we broke compatibility with the Hive table format purposefully so that we could fix a lot of these issues. The other formats, as I understand them, and I'm not an expert on the other formats, but they tried to maintain compatibility so that you can easily go between Hive and the other tables. The problem there is you still end up with problems like a user drops a file in a directory. Should that file be part of your table? I mean, if you want it to be, then you that presents a huge number of problems, because how do you maintain like a materialized view or a secondary index if users can just drop files in random locations and that's supposed to be part of your table? You don't know when those things happen.
Yep.
And then on the other hand, like if it's not supposed to be part of it, you've just broken compatibility with Hive, which you said you maintained. So like if you look backwards and try to maintain those Hive concepts and constructs, then you're really shooting yourself in the foot. And I think Iceberg has done well trying to maintain what we can, but really like knowing where we need to break compatibility and not being afraid of doing it.
That's an interesting philosophy too, yeah, because there's always this this in any engineering thing is like, if it's not broken, don't fix it. But then it's like, but everybody's kind of idea of what does broken mean? It's like it's kind of broken, and so where do you draw the sand in the line and say this is broken enough where I think we need to fix it?
So for us, those were things that were persistent problems for our end users.
Yeah.
In the Hadoop ecosystem in general, I think that we put way too much on data engineers because we were all excited about it in the early days. We were like, hey, we can write code and control our own data, and we have all this control. But now we've gotten to a point where we still say, oh, too many files, that's the data engineering problem. Oh, you want to prepare your data so that the database can read it easily, like take advantage of Iceberg's tree pattern and make it real easy to do point lookups. Oh, you need to know how Trino is going to perform that query and what Iceberg metadata, and basically sort your data ahead of time. Like, why are these things data engineering problems? So we really, one of our central tenets is usability. We want to take care of those problems that were persistently hurting our data engineers, because like schema evolution is a perfect example. Data engineer comes and renames a column in the Hive metastore, writes some data, then finds out Trino can't read it because the Hive metastore doesn't track former names for columns. So like all of a sudden they accidentally dropped a column and added a new column on that rename. Well, now they've got data written in both formats. So how do we fix it? This is a data engineer's week where they screwed something up by running a DDL command, and then they've got to spend all their time fixing it, and then they come back and they're like, why did you guys let me do that? And we're like, oh, well, it's kind of a data engineering problem. That's why we
Why did you do that?
Yeah, I mean, our documentation says don't run rename. Come on, you can rename in C. Like, what?
Yeah. Oh my God. I've done that before too. That's the thing is like when we had to, luckily we had backups in Kafka. So we were just able to just revert the change and then just like spit the data out for that. I think it was like a half a day that we had that in prod, but it was just like, oh my God. Like, so yeah, these things are, I mean, I think anybody who's been in data engineering and dealt with Hive directly, like has seen this problem at least, maybe 5 times, at least enough times to count on one hand or maybe two.
And that's not even the worst one. So the table evolution thing, right? So you have a brand new data engineer coming from, say, a Teradata or a Vertica background. They're perfectly happy using Presto for everything, which is great. We help them set up a pipeline, but they get their table DDL wrong and they don't know about partitioning the first time. Mm-hmm. And so everything works great for a month. And then they realize, oh, my queries are running really, really slowly. How do I fix this? Oh, well, the answer is you create a new table, load all of the data into that table. Yep. Then you rewrite all of the queries because your queries have to know about partitioning in Hive tables, and then point them all at the new table. Oh, and if you want to, you can rename at the end to move it back, but you'd have to rewrite the queries again. And unless you're using DBT, but like those sorts of migrations, that takes several weeks, especially if it's, a year down the line and you need to go from daily to hourly partitioning or something like that.
Yeah.
And so that's why like having that logical physical separation that I was alluding to earlier, like it's super important to have these things. And I think that being forward looking is going to save data engineers a ton of time.
And I realized so David, did you have anything to add to that? Like I realized that we got really into Ryan's answer and just kept going on that. I mean, was there anything else from your perspective, like us coming from like the readers and users of Iceberg, that you could add to that, or is that pretty much?
Well, so as a database guy, like I love the immutable snapshot model, like that you get atomicity. And as an implementer, I love like the strong specification. But Ryan nailed the two things, like for users, is like the schema evolution and the hidden partitioning. Like you're just like, those are the number one things that people always run into in Hive.
For sure. And
schema evolution, we ran into that at Facebook all the time, and users work around it. Like a very common pattern was a table would have a few top level columns and then would have a big JSON blob. And people did that because it was just too hard to make changes to the table schema. So yeah, just throw all your stuff in JSON. You never have to touch DDL. You never have to touch the systems that are ingesting the data. But then, well, how do you query it? You've got to know what's inside of there. Yeah. You can't just describe the table. Your queries are super expensive because parsing JSON is very CPU intensive. It takes lots more IO because you've got to read the entire JSON blob instead of just the columns you wanted to pick out. So making the format more efficient and work for users so that users can just use it easily and have it come out efficient is a huge win.
For sure.
I would add to that things that we haven't covered but are along the same lines. Making sure we got types right. Having decimal. And then, well, I mean, as right as any database and ends up getting them in the end. But also nested types. So you can evolve types, a struct within a map, for example, and things like that I think really, really help. So it's not just at that top level. You can add or remove columns, but you can rearrange, you can go into substructs and move things around. So you can actually model the data however is natural for a data engineer rather than resorting to that JSON.
Yeah.
And you can do that across whatever data format, well-specified data format you want.
I know
so the keyword specified came up again, and I think that's a core benefit. I think that at least enables the integration with Trino quite a bit. I mean, David can tell us more about that, but I think the fact that you have a spec that goes into that depth of data types and all that kind of stuff, that's extremely useful for anyone who needs to interface with the system and implement sort of like interactions with it, which obviously we have done in the Trino community. I'm just curious, what led you down that idea of having that spec, and then what's your experience now that you have it in terms of like, are there other people that want to like implement towards that spec, and where has it been used already, like that kind of aspect, and how much does it evolve? Like that would be really interesting, I think.
So I think it's really important to keep this as a spec and a reference implementation. We internally do have reads and writes in Python written, and we're working on getting that external. The challenge there is that Python doesn't really have a common framework for a lot of things like we do from the Hadoop community. So Hadoop, we have Spark, and so like that made sense for us to integrate on. In the Python side, you've got like pandas, which can't represent all the types, and then newer Arrow, but that doesn't have like some of the interaction that you're looking for, and so it's kind of hard to determine like if you read a table from Python, what do we produce? So we have some internal tools that work with it, but anyway, that's the challenge on the Python side. We are doing a Python implementation. We think of it that it's really important for this to be something that can be implemented. I worked on Parquet for a really long time, and that was great there because we had people, Python was one of the earliest ones, but a Rust implementation came up. We just want this to be something that is not locked into the JVM and Hadoop communities. There's no reason why you can't use this for a variety of use cases that have nothing to do with the Hadoop ecosystem, right? This is a at-rest format that has rich features for storing data as tables. You should be able to do that anywhere. So like we have people that are writing like logging applications. So from all of our runtime systems, we collect the logs, send them off. We have a system for crunching them down and putting them into Parquet files and committing those to Iceberg tables. All of that happens to use Java because we use a lot of Java, but you can imagine like having that use case, wanting to manage your logs and build this system in some other language or framework, and then still back your dashboard or your logging application front end with Trino. And that's what we're doing. So that interoperability, I think, is going to be more and more important because you can directly interact with tables through a library and then have a rich SQL experience accessing that data later, or a rich experience with like data frames if you need to do model training and things in Spark.
So what are some long-term goals with the spec actually? Like, so I know like technically it says on the site, like, this is still kind of in progress, right? Is there like any idea or goal of like getting that done, or is it just going to be something that's, kind of perpetually evolving and we're just waiting to see what indicates that it's the right time to make this is V2 and here's where we stop? Like, are there any indicators of saying that's coming up?
Yeah. So we actually have V2 milestones. We're about done with the implementations, and then it's just a matter of finalizing the documentation in the spec. So the incrementing number is really just a compatibility thing. Mm-hmm. V2 is releasing file deltas, so you'll be able to encode deletes against an existing data file to say rows 3 and 7, those are deleted. Which is important for like GDPR use cases.
Yeah.
We know that V1 has to be V1 and can't be compatible because a V1 reader has no idea that it needs to merge in deltas against that table. So like, you have to break compatibility at those events. We're also using that as a way to get in new requirements. So if you're writing a V2 table, you need to write the list of partition specs that are in this table, not just a single one that applies to the table. Things that we've evolved in the spec in a backward compatible way in the past. So yeah, those are really like compatibility changes where we need to cut a new version number. Then you can manually update your table, or somehow update your table to V2 in order to enable those things and start writing the new metadata.
Got it.
We have a pretty strict compatibility policy, right? Everything is backward compatible. And within a version number for the spec, we guarantee forward compatibility. So the first reader where we've said, say, Iceberg 0.12 is compatible with the V2 spec, 0.12 will always be able to correctly read that data in V2. No matter what we change about it in the future, if you're running a V2 or a V1 table, we guarantee that that version is going to be correctly reading the data. So, we really want this, again, to be something that we can evolve over time with those guarantees to help you reason about the different versions of the spec.
Gotcha. Would V3, so if you're on V1, you can't make two jumps, right? You're saying it's just the immediate forward, or it's totally like if you come out with a V3, are you concerned about forward compatibility from V1 to V3, or is it just per like?
So V1 can only read V1. V2 can read 1 and 2, and so on.
I see.
You always have backward compatibility, so you can read the older versions. And in fact, like, all metadata for older versions is still valid. We have rules for updating it for the new version.
Okay.
So, for example, V1 doesn't have sequence numbers, which keep track of when deletes happen in time.
Okay.
V2 does. So if you're reading V1 metadata in a V2 table, you say, oh, I know that everything in V1 had sequence number 0, for instance. But yeah, there's no forward compatibility outside of versions.
Okay.
So you can't read a future version with older readers, or else you are no longer guaranteed correctness.
Yep.
Which is kind of big.
Oh, yeah. Got it. Cool. There was another question I had which was from the time that you had started Iceberg, were there any like kind of really interesting features that you wouldn't have anticipated that, or kind of interesting use cases, I guess, for Iceberg, or has it been pretty like clear cut?
Oh, people have been doing pretty amazing things with this. One of the things that I think is pretty cool is our logging team that I mentioned earlier, building their system for aggregating and writing logs into tables, and then using Iceberg to basically seamlessly expose those logs to people in a feature-rich UI. I think that surprised me, that we have this fairly tight integration between an infrastructure component and tables, right?
Yeah.
They just produce table data, and then they can write everything on top of a Trino database, or Presto for us, but like that's pretty awesome.
Nice.
We also had a couple of use cases that I thought were very surprising, in that Iceberg metadata I described as a persistent tree. So you keep making changes on the edges of the tree as you write new snapshots. It also forms, because we keep track of, at every layer of this tree, information about what's stored in it. You can quickly navigate it. So this helps with job planning. So if I'm looking at a manifest of data files, I know the partitions those data files are in, because I have a tuple of partition information.
Yep.
And I also know like min-max stats for their columns, so that I can prune out files quickly.
Yep.
I can do the same thing at the manifest level. So I have a list of all the manifests that make up some version, and I know the basically ranges of partitions in those manifests. So it forms a coarse index over the entire tree structure, which means if you have just one dimension you want to look up data through, you could get really great performance, like surprisingly fast performance.
Yeah.
So where I'm going with this is we were able to shut down an Elasticsearch cluster not because Elasticsearch isn't amazing in itself, right?
Yeah.
It was because we only needed to search on this data in a single dimension. We were always looking up some specific ID, and we didn't need a live cluster running that data, running constantly with that data.
Especially with all those memory requirements.
Yeah, like the size of the data made it expensive, and we could only keep 2 days.
Yeah.
We changed that to be an Iceberg table. The data is stored in S3 at rest, like nothing, no infrastructure is needed to maintain it. And then the only thing that required was making sure that as data was written, instead of being grouped by time, just naturally by the writes, we rewrote the metadata and pivoted it to be grouped by that ID. So we bucketed the table by the ID, and then we made sure that manifests only covered a certain range of IDs. So that turned the table, rough index into something that Trino could use to really, really quickly zoom in on information. And we were having basically the same performance with data at rest in S3 with a dynamically scaling Presto cluster that we had with a really huge Elasticsearch index.
So you're saying again, that Iceberg is as fast as all these in-memory databases?
Yeah, I mean, it was like, I think our requirement was like 2 to 5 seconds. Well, I guess that really means less than 5 seconds to load all this data. Cool. And because our cluster was so large, like it was taking that amount of time, I think, in Elasticsearch as well. And so like, again, like the use case was we only had one dimension we were querying on. Otherwise, you'd still have to do a huge scan, and like Trino can do that, but it's not going to be that quick.
Yeah, yeah.
But it was pretty amazing to save that much money on this.
Yeah.
The other thing, I'm going to give one more example because I like these.
Yeah, me too.
We used to have a lot of infrastructure for taking data from Kafka and putting it into Parquet tables. And that had several stages because you needed to do these partition swaps. And we had something where we'd create false tables, and those had like 10-minute partitions. And then we'd like have some like special applications swap the 10-minute partitions for the hour partitions. And like, it was weird. At the end of that, we had a compaction process. And so no one really got any data until after the compaction process finished, when all of the hour was complete. So we'd have to wait until the end of the hour, compact it, and then people could read the data to get real Parquet data. Now with Iceberg, we kind of get the best of both worlds because you can append data anywhere in the table without worrying, is this going to be an atomic operation? We have far less infrastructure. We get exactly one semantics, and more importantly, we commit directly to the table. So the data is immediately available within like 5 minutes to query. Then what we do is instead of doing that rewrite at the end, we have a system that picks it up from the remote AWS regions and moves it to the region where we do our processing. So although the data is immediately available, if you wait, say 20 minutes, to give that process time to move the data, then the reads are a whole lot cheaper. So we just put a 20-minute lag on kicking off our ETL on the data, and all of a sudden we've got like way better availability for queries that are just trying to get the latest. We've got basically the same overall picture, like you get your data eventually in Parquet format in the correct region, but that latency is down to 20 minutes, and overall the cost of maintaining this system that would do the partition swapping and stuff like that is gone, because we don't have to run that service anymore. We just have Flink writing directly to a table with our Metastore. So like, there are some pretty cool things that we've been able to do.
Really? Wow, that is awesome. It's like
that, by the way, the Flink committer that is in the Iceberg project now, that is based on our committer. So you get the same feature set. It's pretty cool.
Very cool. Ryan, that was awesome. Like, seriously, this is some really cool stuff. I am so thrilled. Like I've been digging in pretty heavily to Iceberg, I think like the last almost month now. And like now just even hearing you talk about, I mean, these specific use cases of how you've literally like chopped ETL times into, you know, a third of the original time. It's crazy. It's crazy what the possibilities are here. Not only just from, you know, like a technical perspective, but then like a time saving perspective for your engineering team in terms of what problems people are focusing on. That's just huge. And now you can actually go back to kind of your original job, you know.
Can I give you one more that
Go
I'm
for
really
it,
excited
dude. Go for it. Yeah.
Okay. All right. So we've got data flowing through Kafka, right? And we actually have a Flink infrastructure built out so that you can process data in streaming. So basically Kafka to Flink to Kafka or something like that. That is awkward for our users because for our Kafka clusters, we only have 6 hours of retention. So basically that means if anything goes wrong with your job, and this is like data engineer, you know, user job, if anything goes wrong with it, you fix it in 6 hours or you lose data. Or you wake up someone on platform and you say, hey, is this on a cluster that happens to have more space? And can we like, it's a big deal. You're waking up a lot of people potentially. And you've got 6 hours to either fix it or, you know, figure out how you're going to make that data last longer. So what we've been toying with, and I think you can do this with the latest open source release with Flink, is instead of putting Kafka in between these streaming jobs, put Iceberg tables. So you can stream data into an Iceberg table. There, you're not limited by the size of your Kafka cluster and how many instances you want to store data in. You're only limited by how much space you're willing to spend in S3. And so then you can also consume incrementally out of those tables. So every append from the first Flink job can be an input to either a Spark streaming or a Flink application. And you know, Flink will actually read that out, and you can do Flink SQL and manipulate it that way. So we think this is actually a really great way to have streaming infrastructure rather than batch infrastructure.
Wow.
Because you know, your streaming job is constantly running, so it means something that you don't have to schedule and maintain and have, you know, deal with failures and retries and things like that.
And you could still
still like basically you're just dumping things into those tables and you keep dumping them, and you still at the later stage can clean them up when you don't want them anymore, but your time window restriction disappears, right?
Exactly. Your only time window restriction is from how long you want to keep snapshots in that table. And our typical window for snapshots is 7 days, and you can, you know, extend that as long as you want.
It's just really storage space at that stage, right?
Exactly. Like it's how much you want to spend on S3 rather than EC2 instances.
The other thing I wanted to ask you before is when you're talking about those logging dashboards and in general all those use cases, I kind of hear it like implicitly, but I think I wanted to just like get that confirmed from you. Most of the things then end up happening to be queried with SQL, either via Trino or via like Spark or whatever, like some sort of tool, and then you can use the generic dashboarding tools and all those things that are powered on SQL, right? Like, is that what's happening for you?
I think, yeah, we're using SQL to query the data. I don't know that we're using a generic dashboarding solution for this because I think we want to craft the queries in a way that we're, you know, a bit more confident they're going to be quick. And I think that we also do some merging of data from the systems that are batching log data up. So as the log data comes in, if you want that immediately available, like within seconds, you don't want to commit it to the Iceberg table within seconds. You want to you know, have some secondary channel to get that to the user. So I think there's a lot more complexity there, but the vast majority of these use cases are being driven by SQL queries. And I think that that's really where we need to go as an industry. I used to love the control and everything that we have over writing my own ETL pipelines and like I can do anything I want in MapReduce. The problem though is you end up with compiled artifacts that you have to maintain code for. You have to maintain, you know, if you want it to work faster, you've got to do it. It's got to be compiled against an API that is specific. Like it is so much harder to maintain a Java or Scala artifact compared to SQL, where I, as a data platform person now, and not a data engineer or someone writing those jobs, can improve all the jobs by fixing the optimizer or, vectorizing something in the read path. Like, I really think that SQL is the right way to go for maintaining pipelines and applications.
I agree.
I'm sure you guys probably agree with that.
Yeah. ANSI SQL supporters over here as well. Cool. We're getting a little low on time, so I want to move on to our next spot. But Ryan, I could literally sit here and listen to you talk about all these different use cases and scenarios all day. And we're real quick before we hop on to the next thing. How can people get involved with Iceberg and kind of what are some ways that people can either get in touch with you or kind of find you, stuff that you're doing in terms of talks and things like that?
And let you know that they're using Iceberg and loving it, of
as
course.
Well.
Yeah. So I'm blue at apache.org. If you need help, feel free to reach out, probably to the Iceberg dev community first. But if you want to talk to me specifically, I'm always up for that. So dev@iceberg.apache.org is like the main mailing list. We also do everything through GitHub, just to make it easy. So open issues or pull requests, and everything is there, including the spec. You can make pull requests against that.
Cool.
We also use ASF Slack if you'd like to join us there. So we love having new community members. Yeah, please reach out and let us know what you're doing.
Yeah. ASF, for those that don't know, is Apache software. Oh, sorry.
We also have a getting started page. You mentioned like, how do people get started testing this out? It's just a pretty easy Spark. It's Spark based because I don't think we have a good example for Trino. Maybe we'll work with you guys on that. But under Spark getting started, it takes you through a single command to get you up and running with a local catalog instance that'll run Iceberg tables and gets you to the point where you've written a little bit of data and can look at a metadata table. So,
very cool.
Just run through that. It's pretty simple these days.
Well, actually, I'm about to demo that real fast. So maybe we'll take this and eventually merge this into the Trino getting started. Is this basically a pull request I can do against this web page? I'll sync with you on that afterwards, because I do have a little bit of stuff that I've put together that kind of uses Trino specific setup. So I'd like to hop on over right now to the pull request of the week. This is actually one from one of our maintainers, Pratham, and he. Oops, I didn't mean to click on him. He basically had this in on 3.54, our previous release, and had I known that this was in, I could have used this to actually fix an issue that I had on the last Trino community broadcast. So I had kind of showcased the two ways that we can kind of interface with Iceberg. One way was this Java API, and this is inside of the Trino getting started area of a repository that I'm working on right now to kind of grow out our getting started page. And basically, I wanted to kind of, I have two kind of areas that you can look at. You can basically use the Iceberg Java API, or you can, I have basically like a little Docker local setup with Trino and Iceberg sitting on top of MinIO. So you can go in and start up. I have in Docker, I have this, let me pull up the dashboard. I have a couple containers running, basically the Hive Metastore with the database backing it, MinIO, and then we have Trino running on top of that. So so basically, if we have this local main set up to connect to all of those, and here I basically just set up the schema, which in Iceberg nomenclature is just called the namespace. And you can do a lot of further nesting of the namespace if you want to, but for this one, we're keeping it easy. So we'll just call it logging, going off of the examples on the Iceberg site. we set up the schema, we set up the partition spec. I showed you all this last time, and the one other new thing that I added here was I changed the write format default to be orc, because typically Trino likes to work on the our orc format, but you can also use Parquet, which is I think the default of Iceberg. And then we just create the table. Before here, I had a little bit of stuff messing with the snapshot, trying to basically get a dummy snapshot set in here because we had an issue where if we had created a table without actually creating a snapshot from the beginning, we would have a failure on read. And so, very simple little change in here. We basically just, during the get splits, we basically just verify and see if the snapshot's empty, and then we return a proper tuple here. And then updated the test here. So simple change, but had a huge impact on terms of what I was trying to get done last week. And so now we can actually run this. If we look here, I always like to show min.io before we actually run anything. We have a bucket that we created called Iceberg. And so let's go ahead and run that real fast and create this table. This is basically Java code format of creating a table, and you can do this as well in Trino. Let me see if I have a quick create table that I can reference for Iceberg. I don't, but I can add that to the show notes afterwards. I'll be adding all this code that I'm about to run here in the show notes as well. So we basically ran this, and we get back. We basically pull out the table and verify and print out a couple things. So basically, we should have a table that is stored under logging DB, and the table is called logs. So inside here, the only thing that's initially written is this JSON metadata, and that's just basically, believe it's just to store some of the information just about the table itself, not about any underlying data which doesn't exist yet. So you would find things like the schema in there, partition spec, and so on. And then what we can do, and you can correct me at any point if I get something wrong, Ryan, as I'm explaining this, we should now be able to, from Trino, read from this table and just be able to actually read out the empty table. And this is actually showcasing Prothams. So we don't have a snapshot actually written yet because we haven't written any data. So we get those fields back correctly. We can actually even show what the create table would look like. Actually, why don't we do that? Show create table. And then this will be the way I show you what the create table looks like in Trino, in the Trino syntax. So that basically just looks right here. We do see, you'll notice the partitioning on.
A bit small, Brian.
What's that?
It's a bit small if you can zoom or whatever.
Yeah, let me see if there's I don't know if there's a way I can zoom on.
That's okay. We'll put it in the show notes.
We'll put it in the show notes. Yes. So and so basically we get this table back with nothing in it. So why don't we go ahead and insert something into it? We'll go ahead and insert and verify that comes back. We got our one row back, and now we can actually look to see what gets written here in the metadata. So we have some Avro files. We have a new JSON file, which basically still, I think, or this one right here, 0001. And that's basically if there's any updates on the table itself. And then we have a Avro file that is actually one of the manifest files, as well as the snapshot, or I think this is the manifest list. This is the manifest file itself. Is that correct, Ryan?
Yeah, that's correct.
Okay. So then
we've evolved over time.
And then the actual data itself is stored underneath the partition as expected. We have the event time per hour and the level equals error. And this kind of somewhat mirrors what we would have seen in Hive, where things are still stored in these kind of paths. But the metadata, the difference here is that the metadata itself is pointing directly at this particular file versus this directory sitting above of it. So that's the one thing I want to make clear to folks that are seeing this and saying this looks exactly like what Hive did. So now let's go ahead and look at the snapshots, and you can do this in Trino by just specifying the table. You have to actually put the quotations around it and specify the table name, $, and then say snapshots. And this is what Ryan was referring to earlier to kind of tap into that. So what this does is it actually pulls out the metadata from those Avro files and kind of tells you what snapshot. So this is the actual snapshot ID. This is when we actually wrote it, what the operation that was performed with this. So we actually appended data. So why don't we go ahead and insert a couple more values in here. Hopefully I make sure I include everything. Okay, so we've inserted 3 more rows, and of course, if we pull that out, we should expect to see 4. Okay, great. And if we look at the snapshots now, we should see yet another new snapshot. And this one points back to the earlier snapshot that we just did, so that way you know where you're coming from. So really cool stuff here. So what if we actually wanted to view the table, this table at a particular, let's say the very first snapshot, where we just had that value here. So in Trino, what you do for that is you say the table name, use the @ symbol, and then you basically specify the snapshot ID here. And now we can actually read the table at the earlier snapshot, even though if we still read the original table here, we still get all of it, but we can basically look at different time, you know, is essentially what they call time traveling, where you can look at these old timestamps or old snapshots of your table and time. So let's do a real fast overview of like adding a new column. And these were some of the features we were talking about that these are things that were like impossible in Hive, totally impossible in Hive. So let's go ahead and add a column called severity. And we'll add this integer here. So we can do that. And now let's go ahead and show the create table for, well, I'm not going to show the create table because it's too small. I will show the output of that in the show notes. And now let's just basically pull the table back. And now we have this new column severity. The only thing that's changed is that they're all the previous ones were just set to null. And so if we, again, do this snapshot again, we'll notice that no new snapshot was added for adding this column. That's, I believe, only going to be introduced inside of that JSON file that we showed before. Is that? I think that's the thing that happens.
All schema evolution is a metadata operation.
Got it.
So unlike, I think, other formats, like you have to rewrite all your metadata, or sorry, rewrite all your data in order to do certain schema evolution operations. Mm-hmm. But it's always a metadata operation in Iceberg.
Got it. So in that case, yeah, you're not going to be able, if you add a column or go back, like that's not going to be other than the state of your actual data at that time, you're not going to be able to kind of go back to whatever your schema was in this previous change, right?
I mean, you can drop that column again.
Yeah, right. Yeah. But it wouldn't be something that would be tracked by these snapshots. That's only tracking data in time.
That's true. So we are moving to where we're tracking the schema that was current at the time of a snapshot.
Okay.
Just so that you can time travel back to that point and know that you're seeing the exact same results.
Got it.
But we haven't added that yet.
Got it. Okay. So I think I do. So now we do an insert and we add a new value for that severity. And then we can now see when we pull the data out, we now have all the rest null, but then this new one is severity 1. And so that's going to be how you add a new column.
Let me ask a quick question about this. And that's probably for David and Ryan. With recent releases of Trino, we are getting update support, like SQL update. Does that mean that theoretically, once we support update in the Iceberg connector, we could go back and update those old records for the new field?
Yeah, that's correct.
Yeah, and that's supported in Spark as well.
Very cool.
Awesome, cool.
So
I guess I'll have to talk to David Stryker to get that added soon.
It's really cool stuff. So now we're going to rename the severity column to priority. And again, this, for those that haven't really messed much with Hive before, this may not seem like a huge revelation, but if you're somebody who's having messed with any Hive tables, like this is like groundbreaking stuff in terms of like how you manage this stuff and how this is actually being done on the insides. It's really great, and basically just giving you what you would probably assume should be things that you would need. So we're going to go ahead, and now that we've renamed this, we named from severity priority, same fields, but now we just get the the value or the field named as priority instead. And so let's go ahead and alter that table to now just drop that column, and as we would expect, we basically lose that column's worth of data. And then let's go ahead and show the snapshots. The only thing that was tracked out of all that stuff that we just did by adding and renaming was that one extra append of that new row that we appended back here with originally with the severity timestamp. But now that's gone. The other last thing is, while you can also read from these snapshots, and just see, that particular moment in time, you can also move back to, so let's say we want to get rid of that new one, that new field or row that I just added with the severity field. We can, as you would expect, like I had shown before, you can read and just check, say, hey, let me make sure that this is where I want to actually revert back to. And you can actually take that and say, okay, this is exactly the timetable that I want to move my my dates back to, or move my snapshot back to. So you can actually permanently roll back the system by calling system rollback to snapshot, and that's a function call that actually enables us to now, if we query the table logs, we now don't see that fifth row in there. Now, that doesn't mean that it's permanently deleted. In fact, that snapshot is still there as long as you haven't deleted it yourself. So we could actually move back forward, and I call this one back to the future. So if we want to move back forward to this snapshot, we can actually do the same roll back, even though it's rolling forward. And again, we can see that that row that we had rolled back and lost is still living there inside that snapshot. And so that's basically it. I wanted to just kind of go through a quick tutorial of how you can take advantage of a lot of that this capability functionality that is really rich functionality. It's almost like a Git level functionality for your files sitting inside of your data lake. So awesome. I mean, really awesome project, Ryan. Like, thank you for stepping up, as well as the community that sits around. This is not to you, as well as the Iceberg community at large. Like, thank you all for all the amazing work that you all do and are still doing and continuing to this day. It's just really incredible. And we're hoping that we can do a lot more and get a lot more involved in getting more traction there as well.
Yeah, we're really looking forward to, I think, partnering with the Trino community, because there's a lot that we can do here. Getting those to update commands done and working is going to be fantastic for our users. It's such an improvement over the way we've been expressing jobs. Again, it's going to take a lot of load off of data engineers, rather than read this over here, filter out what I don't need, read this over here, union them together and write. It's just like, oh, okay, just merge. Here's how to create rows. And it's much better. Really looking forward to that. I think Trino can be a wonderful, like, first class front end to Iceberg tables. Totally. And I'm really excited about the possibilities there.
Awesome. Have a couple more things that we need to cover from a implementation standpoint. If you need to run, Ryan, I know we're going way over time today, but okay.
It always happens, Brian.
I pretend like this is not a normal thing, but I do want to quickly cover our question of the week. And this is a very fast one, and one that's become less commonly asked, mainly because we've been doing a lot to fix our test pipelines. But this is more to our contributors that are contributing code a lot. Is a lot of times when they're running the test pipelines, there are failures. We have some tests that can be a little flaky, and we've been doing a lot of effort to actually identify those and basically take a look and take care of those. We never just like mass ignore tests. We need to get to the bottom of why they're failing. But we now have a very streamlined way of like actually annotating tests that are flaky, so that we can primarily focus on fixing those tests and spend a lot of development time into that. And so the test pipeline has gotten better from what I've seen from a peripheral point of view. And so this hack hopefully won't be needed as often, but unfortunately there are people that are asking a lot of times, like, how do I rerun this test pipeline if I get knocked out by a flaky test? And so one easy one-line hack that you can do to update your pull request, if you have a pull request, you just need to do this git commit amend no edit and then just do and do a git push -f. You can copy this from our show notes and just basically run this on your local forked version, push that out to your version again, and then basically that will, without adding any new commits or anything like that, it'll basically invoke a new test to be ran. We can't unfortunately give anybody the ability to run tests themselves, or else they would be getting read access to some of this, and we need that to be only the maintainers. So hopefully you understand that. But this is a pretty easy way to kind of get to kind of, I guess, kick the side of the system to run the tests again. Other than that, I would like to see if let me see if Rose wants to join. And before she joins, I'm going to basically talk about our meetups that are coming up. So let's see. We have some inaugural Trino meetups. That's going to be David here joining me along with Martine and Dane and Eric, the original band on the Presto group that started at Facebook. We're all getting together just to kind of update everybody on what's going on in Trino. Obviously we have these setups, but a lot of people don't really like to maybe necessarily hop on Twitch or watch YouTube or anything like that. So what we want to do is just have an inaugural virtual meetup, and we're going to be splitting it up between EMEA, APAC, and the Americas. So having different meetups for each of those, and basically just talking about the state of Trino, what to expect, what's coming up. A lot of cool things coming up that I should probably just not give away here, but we'll talk more about that. April 21st, 5:30 Eastern time on the Americas side. And then you can look up you want to look up the other one. There's America's one, and then there's an EMEA one, which is all Europe and Middle Eastern Asia, and then also the APAC one, which is all pretty much kind of anywhere from India over to Japan. So looking forward to that. Let's see if Rose is available. I see she is, and so let me get her. Rose, are you available to?
I'm here. Am I still muted?
Yeah, the problem.
The question.
Let me see if I can.
I don't need to be seen. That's not important. I can just be a floating head ghost. We can pretend I'm the bunny.
Sounds good.
Here.
I'll see if here. I think I know what I need to do. I need to open up. I need to open up Zoom here. There we go. And let me. Oh my goodness. I cannot.
We're doing it live, and I have about 2 minutes.
Yep, sounds good. Okay, well, go ahead and talk to us about Write the Docs. I'm actually just going to do the code scene and bring up your blog that you wrote here so wonderfully for us.
Perfect.
So, welcome Rose Williams to the show.
Hi, everybody. I'm Rose. I'm actually a open source docs enthusiast, and I do a lot of community organizing for Write the Docs. If you're not familiar, it's a global community of people that care about documentation, especially for open source, because we've seen that documentation, especially when it's good documentation, is really core to those communities. So I'm here to tell you about Writing Day and the Portland Write the Docs conference. So that conference is coming up at the end of the month, and Writing Day is the first day of that conference, and that is April 25th. And wow, I haven't been on a stream in a while. I apologize. All of my words just Writing Day is really cool because we get a bunch of open source communities together in one room, and we welcome new contributors. And so it's designed to help you onboard new contributors, more specifically writers, but really anybody can join and get them set up and contributing to your community. So Trino is going to be coming out. I'm actually organizing and coordinating that particular event, so I'm hoping that I can pop over to the table a couple times. But I will be floating around the entire event. But I've been working with Manfred and Ryan to set up a filter to filter some good first-time issues that are great for docs. And also we're putting together some issues where we can test the docs and kind of hammer away at them. So if you're interested in coming aboard and helping us with that, there are still tickets available last time I checked. And I also organized some local Write the Doc stuff. And so if you're curious about Writing Day or any local organizations in your area, I am totally happy to help. And you can find me on Twitter. That's the easiest, or on the Trino community, or on the Write the Docs community.
All right. Yeah. Thanks, Rose. This is a great way for anybody who's kind of like got the wet feet. They've never really done open source, and you're not really sure if, especially if like we have a lot of people in the community that like don't know how to write Java or things like that. So like, you know, people immediately think of code contributions, but documentation, like, I mean, this is one of the things that I was saying like earlier in the show, like it's, getting good documentation, getting things very clear and out there and usable for anybody who's learning the system. It's huge, and so it's a very, very helpful thing. And there's not enough of you know, of us that are working on it. I mean, we always need more people writing good documentation. So really welcome anybody who's been in the project for a while. Please join this, as well as anybody who is you know, especially those of you who are new, who are not sure where to begin. This is going to be a nice like low learning curve type of way to get involved in the Trino project. So so thanks, Rose, for joining us and telling us about Writing Day, and we'll have a lot more about that in the show notes. And with that, does anybody else have anything they'd like to do in terms of parting thoughts before we take off?
I just got to jump. So thank you so much for having me come on for 3 minutes.
Thanks, Rose.
Bye.
Manfred, you got any closing thoughts?
356 is in the pipeline, man.
Looking forward to that, definitely. Thanks again for joining us today, and Ryan and of course David. You're always a very happy addition to the show, and look forward to our future contributions together.
Thanks, everyone.
Cool. Thanks.
Thank you.